Next, magnetization of magnetic materials. Now, magnetization is the process of making a magnet from a magnetic material. The magnetism may be permanent or temporary. The methods of magnetization include single touch method, double touch method, and electrical method. First, single touch method. Place a soft iron piece AB to be magnetized over a table. Take a bar magnet and place one of its poles on the soft iron piece as shown here. Stroke the iron piece with the bar magnet. When the magnet reaches B, lift it and place it back to the position A and repeat the process several times. The upper side of the soft iron gets magnetized. Now turn the iron piece upside down and magnetize this side in the same manner. The point A will get the same polarity as the pole of the magnet touching it. When this piece is brought near some iron nails, it attracts them, indicating that indeed it is magnetized. Next, double touch method. Place a steel bar to be magnetized on two bar magnets as shown here. Now place opposite poles of two strong magnets at the middle of the steel bar as shown here. Move the magnets towards the opposite ends of the steel bar, keeping the magnets inclined. On reaching the opposite end, lift the magnets and place them back to their respective original position. Repeat the process over several times. The polarities at the ends of the bar are opposite to those of the ends of the magnets used. When the bar is brought close to some iron nails, it attracts them, indicating that it is a magnet indeed. Next, the electrical method. The bar to be magnetized is wrapped around a long coil of insulated copper wire, which is connected to a source of direct current as shown here. When the circuit is closed, a strong direct current passes through the coil and the bar becomes a magnet. The polarity of the bar depends on the direction of the current. If the bar is viewed from one end and the current is seen to be flowing in a clockwise direction, that end will attain south polarity. If the current appears to be flowing in anti-clockwise direction, that end attains north polarity. If it is a steel bar, it becomes a permanent magnet. If it is a soft iron bar, it becomes a strong magnet and is called an electromagnet. It is a temporary magnet which loses the magnetism as soon as the current flow is stopped. Finally, demagnetization. Demagnetization is the process of removing the magnetic property of a magnet. The magnetic property of a material can be partially or totally destroyed by rough handling, heating, induction, or electrical method. Hammering, dropping, and rough handling of the magnet can demagnetize it. A magnet loses its magnetism if it is heated above a certain temperature called its Curie point. The Curie point of iron is 770 degrees Celsius and that of steel is 808 degrees Celsius. That of nickel is 358 degrees Celsius and that of cobalt is 1121 degrees Celsius. If two magnets are placed side by side with similar poles together, each induces opposite polarity in the other. As a result, the magnets lose their magnetism. To avoid this self-demagnetization, The magnets are placed in pairs side by side with their unlike poles together as shown here. Finally, the electrical method. The bar to be demagnetized is placed inside a long coil of insulated copper wire in the east-west direction. The wire is connected to a source of alternating current. The circuit is closed and the current slowly reduced to zero. The magnet loses its magnetism as alternating current changes direction continuously. This changing of direction of the current disturbs the alignment of the magnetic domains, resulting in demagnetization.